So we are back on our juice making plant. So for a more complicated process, you'll have more instruments of different kinds because there are many variables and aspects of the process that you need to consider, and all these inputs and outputs needs to be wired to your control system. So we'll just quickly go through this type of plant that we have and the various instrumentation that is involved and why you'd have it. So simply, this process will work by, you'll have a concentrate of your juice. So if you imagine when you're making oros, this is the oros that you buy from the shop, which is your concentrate. And then you're going to have your water, and let's assume it could be still water or sparkling water. Then you're going to have your mixer, and your mixer has the agitator. Then you have your storage vessels. So how this will work is that basically you need to transfer this concentrate to the mixer and also transfer the water, then mix it up in the mixer. And then when the mix is ready and it's at the right quality, then you can then pump it to your storage vessels. So that's how it works. So in a typical tank in industry, you'll get various instruments that are found in a tank. So for this particular tank for concentrate, you'll have a pressure transmitter, a level transmitter, as well as a temperature transmitter. A pressure transmitter is usually mounted at the top. So say for example, you need to control the amount of pressure or know the amount of pressure of the concentrate inside this tank. If it is an important variable, then you'd mount your pressure transmitter on that tank. Level is important because you don't want to overfill the tank, as well as you want to know how much concentrate you have currently in the tank. Temperature as well, you want to control the temperature of the concentrate. You don't want it to be too hot or too cold so that it such that it affects the quality of your concentrate. The same can apply for your water tank as well. If it's sparkling water, then definitely you'll have a significant amount of pressure here at the top. Your level, you need to know the quantity or how much water you have in the tank, as well as your temperature transmitter. So within these group of instruments that you have, you'd find different technologies for temperature transmitters, level transmitters, and as well as your temperature. For your pressure transmitters, level and temperature. Typically, pressure transmitters, they use a diaphragm, so they have a sensing diaphragm at the end. With the more modern temperature transmitters, you don't really see that mechanism. It is very compact. Level transmitters, there's a lot that you need to consider when choosing your level transmitter. There's various technologies that are involved, and you need to pick the right one for your process. It could be your radar, ultrasonic. You can even get your hydrostatic level transmitter, which uses a pressure measurement. You can also, on your temperature transmitters as well, there's various kinds that you can get. You can get your thermocouples, thermistors. Typically in industry, what you'd find is your RTDs, which is your resistance temperature detector. Those work on the amount of resistance. Then there are also different grades of your RTDs. So I'm not going to go much into the instrumentation technology. I can do that on a separate video. So moving along with this, in a particular process, you'll then have a valve at the bottom of each tank, and this valve then allows the contents of the tank to flow out into the tank to our mixer. After the valve, you'll have a pump, and then this pump will pump the concentrate to the mixer. Then typically after the pump, you'd find a flow transmitter. Flow transmitters, they'll indicate how much liquid is flowing in the line. As well, with flow transmitters, there are various technologies that you can get. Typically in industry, you'd find a mag flow, a turbine flow meter, a Coriolis flow meter as well. Those are quite popular. It all depends on the cost and the accuracy that you want to get for your process. So this is our plant with its appropriate instrumentation for the conditions that we need to consider when controlling our process for this particular plant. And then coming to our agitator as well, to our mixer as well. On your mixer, you'd have your agitator. When the liquid inside the tank has reached a certain level, then the agitator will then start to spin and mix our process. For this kind of process, you'd want to put an analyzer. An analyzer is an instrument that will give you, like, maybe let's say the concentration of the mixer that you have here. So you'd know the ratio at which you want to mix your concentrates and your water, and then you'd want something to give you feedback on if you've achieved that ratio and that concentration you're happy with, and that's the concentration that you want to achieve. Maybe as well in the mixer, you'd want to also control temperature. You know that the mixing of fluids is affected by temperatures. For instance, if you want to dissolve fluid A on fluid B, then temperature might play a role depending on the chemistry of the fluids that you are mixing. After this, you'll have our pump, and then we have our valves as well. In this case, the valves and the pumps, these are our output devices because these will receive the signals from our control system. Then the pressure, level, temperature, and analyzer, these are our input devices, and these transmit their signals to the control system. What we do in process control is that we are going to be focusing on writing the program on our controller, and the controller that we're going to be focusing on is the PLC, which is a programmable logic controller. Then we focus on writing the program and then loading it onto our PLC. Then the PLC can then be able to control this process for us. In order for us to write the program, we need to have a full understanding on what is required from the process side. So for instance, the condensate to water ratio could be, let's say, 1:3 maybe, and so you'd know that for this amount of liters that you put for concentrate, you must put this amount of water, and you can measure how much you put for each liquid using your flow meter. So now you can begin to see the importance of the flow meter. Then from the process interlocks or things that you need to supposed to look at, you can even tell the PLC that, okay, make sure that the level in this tank is always maintained at 70%. For water, we want it to always be maintained at 80% so that we do not starve the process. You can also control things like after you've put, let's say, 50 liters of volume onto the mixer, you can then start the agitator. Then you don't want the agitator to start immediately when you run the process. So those are the type of things that you look at when you're doing process control, and those parameters or the way that the process should run, that is what governs how you are going to be writing your program. So as I said before, the controller doesn't know what to do. The brain and the intelligence sits with you. Typically in an industry environment, you'd get this information from the process engineers. The process engineers will determine all the process variables that we as automation engineers are supposed to look at and control in order for the quality of the product that we want to produce to be at the correct specifications. So if you're working with your process engineers, they'll give you a diagram called the PNID, which stands for Piping and Instrumentation Diagram. That will show you the type of information that you're expecting to get from the plant, as well as the outputs that you are supposed to provide from your control system in order for the process to work well as to achieve the correct quality of the product. So as I said before, with process control, this can be done manually, but can you imagine the amount of labor that is required for you to control this? Like, you need to have a guy that's controlling the pressure, a guy that's controlling the level, the temperature. It is really not practical. So what we do is that we need to wire all these signals to our control system, program the control system, and let the process run automatically. The results are quite good. Control systems are better at repeatability and accuracy more than humans. It is also not feasible to have a lot of people running this process manually. A lot can go wrong, equipment will break. So that is why we do process control, and the importance of instrumentation is that they provide the signals to our control system. Without the instruments, basically the control system or your PLC is blind. And for you as an automation engineer, it is crucial to understand the mechanics, the chemistry, the safeties, the importance of the quality of how this process should work, because that will govern how you write the program. So those things are quite crucial, and that's why we're gonna start our series by looking at what happens before the signals reach our PLC. Then once we have a good understanding of that, we can then go into writing the program, and because we'll have a good idea of what the program needs to do and how we need to design it.